how about one more example? So we're going to use this where we have P4 reacting with Cl2 to form PCl3. With regard to relative amounts, we have 1 mole of P4 reacting with 6 moles of Cl2 to form 4 moles of PCl3. So we can make sure that this is balanced. We've done this previously, where we need to make sure our P's are equal to our Cl's on both sides. So I get what? 4 phosphoruses here. How many Cl's do I have here? I'm liking 6 times 2 or 12. How many P's do I have here? I'm liking 4. How many Cl's do I have here? 4 times 3, I'm liking 12. So yeah, it's balanced. So let's go ahead and work a couple of stoichiometric calculations with this balanced equation. Before we do that, let's take one more quick look. I think we saw this video before, but it's the one that reminds me of.
In this reaction, a single molecule of phosphorus, P4, reacts with 6 molecules of Cl2, chlorine, to produce 4 molecules of phosphorus trichloride.
I think what's so striking about this one is this is your P4, and those bonds between the 4 P's break, and these bonds between the Cl2's break.
In this reaction, a single molecule of phosphorus, P4,
cool?
Reacts with 6 molecules of Cl2, chlorine, to produce 4 molecules of phosphorus trichloride.
Swing your partner round and round. So we're going to do a couple of problems here together, and let's see what we got. It says, what mass of P4, so question mark grams, is needed to react with 1.25 grams of Cl2. 1.25 grams of Cl2. So can you see where we're going to go from grams of Cl2 to moles of Cl2? How? Using its molar mass. And then we're going to go moles of Cl2 to moles of P4 using what? Stoichiometric ratio. Going to get tired of hearing this, aren't you? Then we're going to go from moles of P4 to grams of P4 using what? P4's molar mass, exactly. And then that's the first problem. And then the second problem is what mass of PCl3, so question mark grams of PCl3, can be formed from, again, 1.25 grams of Cl2. And here it just says that you have sufficient. The word sufficient means you have at least enough to use up all of your Cl2. You have extra. You have abundant amount of P4. So let's see what we got. Knock out our 3 molar masses, if that's okay with you. Again, you have to show this on a test. Do it in the margins or whatever, but of course the decimal number for phosphorus is 30.97 times 4 because it's P4. Cl2, we have 2 times the decimal number for chlorine. PCl3, we have to count for the phosphorus, and we have to account for the chlorine there. Now, notice one thing, and again, notice that these molar masses, oops, I guess I want to do that. These molar masses do not depend upon stoichiometric coefficients. They do not depend, they're independent of stoichiometric coefficients. The other thing is just keep in mind that for each of these masses, you could unzip them or unpack them in grams per 1 mole. Okay, so for instance, that 123.88, that's grams of P4 for 1 mole of P4. So be able to unpack them as you use them. All right, here we go. So the first one is we're going from what? Mass of Cl2 to mass of P4, aren't we? So we're going to start with the mass of Cl2 over 1. What does the next term look like? It's the molar mass of Cl2, the flipped version, so that 1 mole of Cl2 over 70.90 grams of Cl2. Grams of Cl2 cancel. Now we want moles of Cl2 to cancel. Be left with moles of P4. What does it look like? Hopefully you got this, where we're going to put 1 mole of P4 over 6 moles of Cl2. Okay? Alright, moles of Cl2 cancel. We're left with moles of P4. Now we need to use P4's molar mass to get to grams. So what does it look like? Like this. 123.88 grams of P4 over 1 mole of P4, the unflipped version of the molar mass. Round to 3 significant figures, I get 0.364 grams of P4. Now, if you're thinking, why can't I just take this mass and add 1.25 grams, which is your Cl2, to get the mass of PCl3? And yes, you can in this case, but we're not going to do that. To get the mass of PCl3, again starting with the mass of Cl2 with sufficient P4, so the first two terms are actually going to look the same as the last problem we worked. We always have to go from grams to get it to moles first, and then we can use that stoichiometric ratio. Now this term will look different because we want moles of Cl2 to cancel. We want to be left with moles of PCl3. So what does that look like? It looks like this. I get excited when we have big numbers of stoichiometric coefficients. So that's pretty big. That 6 came from there, okay, and that 4 came from there. Stoichiometric ratio. It's the recipe, okay? So we're left with moles of PCl3. Now how do we get to grams of PCl3? Using its molar mass, the unflipped version of the molar mass. So 137.32 grams of PCl3 over 1 mole of PCl3. Very good. Round to 3 sig figs, and I get 1.61 grams, which, yes, is basically the sum of the other 2 grams we had. Now, these problems will be due related to stoichiometric calculations. These are the full-blown stoichiometric calculations. These are what we call grams of something to grams of something else, but we have to go through moles. So for all of these, just like on your test, you need to show all work. That includes your molar masses. You have to use factor label, okay, and you have to round correctly. So there you go.